Welcome to Spark Learning Session. Today we'll be talking about clustering documentation example for k-means. K-means is one of the most commonly used clustering algorithm that clusters data point into a predefined number of clusters. The MLIB implementation includes a parallelized variant of k-means method called k-means. K-means is implemented as estimator and generates k-means model as a base model. We have some input data set called featured columns, and the output data set will be called prediction column. All right, so let's start initializing a few libraries for our program. And libraries we need is this: Spark SQL import Spark session, and we'll run this, and we should do the job. And secondly, we'll start by creating a Spark object by any Spark instance from using a Spark session builder. Spark session builder dot get or create, and we also need to create a data instance, data, and create a data object out of it using Spark, which we just created earlier. Object we just created earlier, and we'll do spark.read.format, and this is in libsim format. SVM format load and sample k-means data. That's the file name we are targeting or trying to load. Let's run this, and it works. Now what we're going to do is we're going to see what we have just loaded. So we'll just do data.show, and this is what we have here. These are the labels provided, and these are the features of the particular data set. Now we don't want labels here. We just want to keep the features. So we'll create something called training data set. Training data set underscore data, training underscore data equal to data select. We don't want all columns. We just want a column called features. That's all we need here. Select and features. Once we have this, we'll have a new data set. And secondly, we want to show what we just created. Let's see what we just created here. Train data. Let's see what we have inside this variable. So we have selected a column called features and put that in your train data. Next step, we want to create a model, initialize a model with some parameters. And let's name that model as a k-means. And class we are initializing is called k-means class. And let's start with few centers. Let's say we have 3 centers with k is equal to 3, and starting seed would be set seed equal to seed 1. Let's start with let's seed 1 be our seed. Next, what we're going to do is we'll use the training data to fit the model or train the model. That's called fitting the model. K-means underscore fitted model equal to k-means dot fit. That's called train data. Now we have fitted model. Now what does it say? This fitted model, once it trains the data, we can look at what are the cluster centers that it describes based on the data it just trained. And we'll look at the cluster centers. This should give us a cluster centers that we just ingested. And these are cluster centers that we just on the data we just ingested. Now, what we're going to do is we'll use the same trained data set and predict the cluster centers. These are clusters we have. Now we'll look at the go back to our data we just ingested and assign the cluster center for each of these data set or which group they belong to. Now we'll predict the the cluster centers for each of the data set using test predictions using test prediction called k-means fitted model transform, and it's going to be a trained data. Now we'll look at the predictions from our data set. Okay. I think there's some spelling error here. Predictions from data set, and these are predictions for each data set. You just predict this will be the group they belong to. Now, finally, we'll do some evaluation here. How do we do evaluation? We'll do the evaluation using the cluster evaluator. That is, this evaluates how the cluster is performing. We'll create evaluation object or tool, and then we'll call that on the prediction model. And we have 0.62, and that's 40 points less than 1. So it's pretty good. Now, I want to conclude by reviewing what we just learned today. We learned about k-means clustering algorithm. We had a data set. We used the data set to train a model, and we went back and to the data we trained and assigned the centers for each of the data set. And we evaluate our training model, and we set 0.6 as a score for the training model. That's all for today. Thank you for learning session.